Welcome back to class, everybody. This is IM1, section 2.3.1. How can I use slope and a point to write an equation? Today's learning target: by the end of this lesson, I will be able to find the y-intercept of a line given its slope and 1 point. By solving for the y-intercept, I will be able to write the equation of the line algebraically. So we've been looking at graphs and we've been able to determine, right, how do we find the rate of change by looking at a line pretty much. And again, it's still the same, right? For all lines, we're going to have our delta y over our delta x, and that's going to be pretty much our slope, right? And then again, where it crosses the y-axis, remember that's our y-intercept, or in this case, or before we were calling it the initial value, right? Still the same thing. So pretty much before this, right? So during this lesson, you're going to develop an algebraic method for writing the equation. And then we're going to, when we have the slope and at least a point of a line. So let's start off with the first question down on the farm. So Colleen recently purchased a farm that raises chickens. It says, since she has never raised chickens before, Colleen wants to learn as much about her baby chicks as possible. In particular, she wants to know how much a baby chick weighs when it is hatched. To find out, Colleen decided to track the weight of one of the chicks that was born just before she purchased the farm. She found that her chick grew steadily by about 5.2 grams each day, and she assumes that it has been doing so since it hatched. 9 days after it hatched, the chick weighed 98.4 grams. So here's where you guys want to take a pause first, right? So they're already giving you some information on how fast the weight of the chick is changing, right? And that's pretty much our 5.2 grams per day. And they also told us that 9 days later, right, the chick weighed 98.4 grams. They didn't tell us how much it weighed at the beginning when it was born, only how much it weighed 9 days later. So our task: determine how much the chick weighed the day it hatched using two different representations of the chick's growth: a graph, XY table, right, and an XY table. Then, assuming the chicken will continue to grow at the same rate, determine when the chick will weigh 140 grams. Okay, so when will it weigh 140 grams? So what is the baby's chick's rate of growth? That is, how fast does the baby chick grow each day, and how does this rate relate to the equation of the line? So we know that, again, 5.2 grams each day. So the baby chick grows by 5.2 grams per day, right? And then again, how does this rates relate to the equation of the line? So when we're talking about a rate, remember that is our slope, right? Our rate of change is our slope. So this would be the slope of the line. And then before graphing, describe the line that represents the growth of the chick. Do you know any points on the line? And then does the line point upward or downward? How steep is it? So here we want to make sure that we're pretty much determining, right, what type of line is this? So if this is changing at a constant rate, right, if this is changing at a constant rate, then we know pretty much that our slope, right, we have a slope. So the slope is 5.2 grams per day. And then we know that the line passes through the point, right? So the line passes through the points, which is pretty much when they told us 9 comma 98.4. So 9 comma 98.4. And then this will point upwards or downwards. In this case, this is going to point upwards, right? Because it is increasing. So the line will point upwards. And it should be like pretty steep. For like 5.2 per day is quite a big number, right? So we can say it should be steep. So now we want to draw a graph for this situation. Let the horizontal axis represent the number of days since the chick hatched, and let the vertical axis represent its weight. So this is going to be pretty much the number of days. So X, right? So it's days down here. And then our Y axis is going to be the weight, right? The weight of the chick in grams. All right. And then say label skill your X approximate title graph growth of a baby chick. So we want to put up here somewhere. So growth of a baby chick. So what we want to do first is we want to start off. So on the x-axis, we should be going by ones, right? So this is going to be 1, 2, 3, 4. And then on the y-axis, I think we should be going, since we are growing 5.2 grams, and then at 9, it's already at 98. So let's go by tenths. So 10. Hundred and 120, 30, 140. All right. So we want to draw a graph. We know a point, which in this case it happens to be 9 comma 98.4. So 9, and then we go up to 98.4, which is going to be about right there. And then if we continue, right, if we continue to go up 5, that's going to be 103.6. So up 5, and then 1 to the right. So it should be right there. So let's draw our line. So I don't know how accurate this is, but we know that for sure it is a line, right, that matches the description that we gave in the previous problem. All right. What is a y-intercept of your graph according to your graph? So it looks like if we continue down here, right, it looks about, I would say about 10 grams. We would say this is an approximation because we don't know the value exactly. So it looks approximately 10 grams at birth, right? All right. And then we want to figure out when will a baby chick weigh 140 grams. So if we continue here, the line keeps growing. So this is where we hit 140. So we can say about, this would be 13, right? 14. So I would say about 15 days later. So approximately, right? At 15 days, the baby chick will weigh 140 grams.